So this is a review of converting numbers from scientific notation to standard notation and vice versa, so and the other direction. So these first ones, we're going to write the answer in standard notation. Standard notation. So first example we're going to do is 5.7 times 10 to the fifth. Okay, remember when you're thinking about these problems, if you do 5.7 times 10 to the fifth, sometimes your calculator will give you the answer if you are able to use these calculators. Or, sometimes when you do it, so let's do 5.7 times 10 to the 12th. Sometimes a calculator is going to give you an answer with an E12, meaning the exponent is 12. So you have to know how to convert these because sometimes a calculator won't do it for you. So if you do 5.7 times 10 to the fifth, what you're actually multiplying by, if you think about 10 times 10 times 10 times 10 times 10, or 10 times itself 5 times, is 100,000. So you're actually multiplying this number by 100,000. Or 1, 2, 3, 4, 5 zeros. But I think students get confused when you say 5 zeros because they just automatically try to add 5 zeros on. But what you're actually going to do is we're going to move this decimal 5 times, because every time you multiply by 10, so if I do 5.7 times 10, it becomes 57. Notice the decimal moved once. If I multiply by 10 again, it moved over again and there's a 0 there. So you're going to move the decimal and make it larger, and you're going to move it 5 times. So 1, 2, 3, 4, 5. And then fill in with zeros. So it's actually going to be 5, 7, and 1, 2, 3, 4 zeros. And put a comma every third number. So it's 570,000. So 5.7 times 100,000 would be 5,700,000s, but 570,000. So that's your final answer. So when you have a positive exponent like this, you're going to move your decimal 5 times. Sometimes you're going to end up with a negative exponent. So what if we did 9.4 times 10 to the negative third power? If you think about the negative exponents that we've talked about, remember it's actually, you have to put it over 1. But instead of making the number bigger, in my opinion, I think it's easier to just move the decimal and make it smaller. So you're going to move it 1, 2, 3. Notice that's a small number. If I had this much money in my bank account, I would think negatively about how much money I have. This one, if I would love to have this, so I always think it's positive exponent, so the number's getting bigger. That's, in my opinion, a lot of money. Hopefully in your opinion too, unless you're very fortunate. And then number 2, this one has a negative exponent, so when you move it, I end up only having 0.0094, and that's not even a penny. I don't even have a penny in my account. So that's why I think about it as this is a negative exponent, meaning the number's getting smaller each time. This one's a positive exponent, so the number's getting bigger each time. All right, so we wrote our final answer in standard notation, or a regular number. Now let's do this one. Write in scientific notation. So let's say I had 6,400,000 and I wanted to write it in scientific notation. Well, think about what scientific notation is. It's a number multiplied by 10 to a power. So we need to get a number between 1 and 10 between 1 and 10 with that exponent. So in order to make this number between 1 and 10, we're going to put the decimal between the 6 and the 4, or the 6.4. So we have to put the number after the first number. Then what you need to decide is how many times did we have to move that decimal. So if we look right now, the decimal would be at the end. But we need to move it so that it makes a number between 1 and 10. So I'm going to move it 1, 2, 3, 4, 5, 6 times. And notice that's a really big number. I would love to have $6.4 million. Notice we say it as $6.4 million because you could write it as 6.4 times 10 to the 6th. You can always get a calculator and make sure that you wrote it correctly. So let's do 6.4 times 10 to the 6th and just make sure 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So yes, that is correct scientific notation right here. So again, your number has to have a be between 1 and 10. So we wrote it as 6.4 times 10 to the 6th power. All right, let's look at this. Let's do one more. Let's do 0.0000452. Again, you're going to write it as a number between 1 and 10 times 10 to some power. So if we look at that, we need the number between 1 and 10. So if you look, I couldn't put it behind the 5 because that would be 45.2. I would have to put it behind the 4. So it would be 4.52. So that's what I'm going to write right here, 4.52. Now I need to decide how many times I would have to move the decimal over to get to 4.52. So we're going to count 1, 2, 3, 4, 5. Now, this was a small number, so we would say that it was a negative 5, and that is how I would get my answer.